There we go. All right, so on this page, basically what you're seeing, you should be on the side that has that, okay? So you can kind of take a look at that. The other thing I want to point out is that on the inside of your periodic tables, on your table, the tables on your table, right? That is where I took that image from, all right? So there's your solubility rules right here in the center, all right? So we've gotten to use polyatomic ions, activity series. Now we're using that center part. So if you remember, we briefly talked about when we would use the solubility rules, and then I kind of left it alone and said, you know what, we're going to come back to this in a later chapter. So now is that later chapter, which is your solutions. And so your solubility rules are basically used to figure out if you're making a precipitate. So is a precipitate formed? Okay, and that's basically what you're doing. So PPT is not PowerPoint. Okay, whenever you see that little notation, it's precipitate. So that we don't have to write the whole word out. All right, on your orange page, that was one of the words that I did not include. So if you forgot what a precipitate is, then please make sure you add it to your orange page. All right, but it did show up on the Schoology assignment, right? So what is a precipitate?
It's a solid formed by a solution, right?
Yeah, so it's a solid that forms when I have two solutions that I mix together. It's one of the signs of a chemical change. All right, so a precipitate is just a solid that is forming when I mix two solutions together. All right, remember back in the day when we were putting these little states of matter in our chemical equations? AQ, what did we use that one for? Well, I know that's what it stands for. What did we use it for?
Like when there's a solid inside of liquid.
Kind of. So it's something dissolved in water, right? So that's a solution, right? So basically these aqueous things, those are going to be your solutions. These solids are going to be your precipitates, okay? That's what you're kind of thinking here. So is a precipitate formed? That's the big question. I don't think we're going to add all those words. Well, yeah, let's write it real quick. So just write yourself that little reminder. Solid that forms from two aqueous solutions. Okay? A solid that forms from two aqueous solutions. This is a sign of chem change. I'm off the paper now. All right, so sign of a chemical change. So we've now heard this word actually in 3 different chapters. So now we're going to actually do something with it. And since you guys now know stoichiometry, we can take it that one step further, and you can actually predict how much precipitate you're going to form. Okay, so that's kind of what's coming up. All right. Okay, so you kind of see some of these words that hopefully you got to see a little bit of their usage and some of the definitions. So we see that we have soluble versus insoluble. I believe those were not in it. Solubility was, right? Solubility should have been one of the words. But what do you think soluble even means?
How easily it's dissolvable.
Yeah, it's dissolvable, right? Dissolvable. That's the informal word there, all right? So soluble just means dissolvable, all right? We also got to really use the word solute and solvent, but I'll focus a little bit more on that tomorrow. Let's just focus on the solubility rules for today, okay? So we got the basics. That's what we're doing. All right, so these are your steps. You're going to look at the anion. Is the anion the first thing or the second thing listed in a chemical formula? Second, exactly. So anion, you always have your positive and your negative, right? So you're looking at that second thing listed. Your cation, and this was your anion. Okay, so you're always looking at the second thing listed in your little chemical formula. Then you're going to find the solubility rules list. Find that anion on that list, okay? Then you're going to read a sentence out loud. You're going to say, so-and-so is soluble or insoluble, depending on where it is. There's two tables here, right? You're going to say that unless, and then you're going to say the rest of it. All right, so NAGSAG is something that if you choose to look it up, that is an easy way to remember them or memorize them. But you don't have to memorize them because you will always have this available to you for Chemistry 1. All right? All right. So for example, let's do a couple of these. I have Li with a little 2 and then S. So I'm going to look at the anion. Who's my anion in this one? Yep, the S. So there's my anion. I did step 1. Find them on the solubility rules list. So I'm going to look down here. I'm going to look. There he is right here. All right, so I found it right there. Okay. I'm going to say the sentence out loud. I'm going to say sulfur is, who's at the top of the list? The word insoluble, right? Or as you can see, I also wrote them to give you like 4 corners on this. It's an easy way to also have it written. So sulfur is insoluble. What state of matter is insoluble? A solid, all right? So sulfur is solid unless, and I'm going to look at what the exception is. So I'm going to read that. It says compounds of NH4 and alkali metal or calcium, strontium, and barium. I gave you a reminder on your page. Alkali metals are group 1. So we got to look at who sulfur is with. Is lithium in group 1 or is he in group something? He's in group 1. All right. Ding, 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 ding. So this rule applies. So sulfur, we're going to say that out loud again. Sulfur is insoluble unless it's with lithium. Is it with lithium?
Yes.
So it means that's not a true statement. What is it now?
Soluble.
Soluble. Now it's aqueous. All right? Okay. So this one is soluble. Oh, wow. Did I just spell that wrong? Yep. Solubule. All right. So soluble. So I'm going to go ahead and put the little state of matter just so I can be ready to put that into my equation. Okay? All right. Let's try another one. The next one we have is barium hydroxide. All right. So barium hydroxide. I'm going to pay attention to the anion, the second thing listed. If you notice, I have 2 elements here. What do I know hydroxide is, though, because we're now in second semester?
Water.
Hydroxide is a polyatomic. That's what I was going for. You're good. You're good. It is a polyatomic ion, right? So we know OH is a polyatomic, so that is what we're looking for in the list. So we're going to look down this list. We're going to see if we can find hydroxide. Hydroxide. All right, hydroxide is right here. So hydroxides are insoluble, meaning solid, unless it's with NH4, group 1, right, alkali metals, or calcium, strontium, barium. Is it with anybody in the exception list? Yes, it's with barium, right? So what does that mean the answer is then?
It's soluble.
It's also going to be soluble, which means it's aqueous. Okay? Okay, let's do the next one. I think the next one I did another exception. I'm so sorry. But anyway, let's look at it real quick. So we've got silver chloride. So hopefully you kind of remember that one from that lab where you formed a precipitate. So that's what we're looking to form. All right, so we have chlorine. That's our anion. We're going to look down the list for chlorine. He's on the top table this time. So now we're saying chlorine is soluble. Soluble means aqueous. Is that a precipitate? Not yet, right? So chlorine is soluble unless it's with silver, lead, or mercury. Is it with silver, lead, or mercury? It is. It's with silver. So we're going to use that to tell us what state of matter and if it's soluble or insoluble. So we did get the exception. So what does that mean? It's insoluble, the solid, which means it's the precipitate. Okay? So insoluble, which means it's a solid. That is a precipitate. Okay? You see how we're doing that? Okay. Calcium sulfate. I'm going to actually change it because I gave you kind of an awkward one. So I'm going to have you actually cross out the calcium, change it to strontium. All right, so strontium sulfate. So there's our sulfate. I'm going to look down the list. It's up in the top table. So sulfates are soluble or aqueous, they're solution, unless they're with strontium, barium, lead, or mercury. Is it with one of those? Yes, it's with strontium. So this is also insoluble. Just kidding. This one is, yeah, it is. Sorry. Insoluble. And the last one to finish us up, we are doing sodium sulfate. Okay, sodium sulfate. Okay, so sulfate is on this list. There it is. Sulfates are soluble unless they're with anybody from that list. Is it with anyone from that list? We have sodium. No, sodium isn't any of those. So now that tells us that it's soluble, okay? Which is aqueous. Okay? So tomorrow, when we're going through this, you're going to take these and you're going to be doing a double replacement. Okay? We'll continue then. All right.